A transmission from the farthest reaches of emptiness, a whisper from a place where our expectations of reality falter, is drawing humanity's gaze toward a distant star that is not our own. What if everything we have believed about the cosmos, about the conditions necessary for life, about our understanding of planetary systems, is about to be upended? The James Webb Space Telescope, better known as JWST, has begun revealing secrets so profound they could transform the very foundation of our understanding of existence. At the center of these revelations is a planet that has long captivated the imagination of astronomers and space enthusiasts alike, Proxima b. A planet that orbits our nearest stellar neighbor, Proxima Centauri, and yet remains almost entirely unknown, a small and enigmatic world suspended in darkness, only 4.2 light-years from Earth. Is Proxima b a second Earth waiting to be discovered, a new home in the void, or is it a perilous world, a cosmic snare where conditions are far too hostile for life? The James Webb Space Telescope, widely hailed as the most advanced space observatory ever launched, has given us a chance to look closer than ever before. Through its unparalleled sensitivity to infrared light, JWST has begun peeling back the layers of mystery surrounding this distant world, revealing astonishing details that were once unimaginable. Since its initial discovery, Proxima b has been a planet shrouded in intrigue. Orbiting a red dwarf star, it seemed to exist in the so-called habitable zone, the region where temperatures could, in theory, allow liquid water to exist. However, appearances can be deceiving. JWST's detailed observations reveal that this small planet faces challenges far beyond anything we experience on Earth. Proxima b completes an orbit around its parent star in just 11.2 Earth days, a rapid journey that hints at extreme proximity, less than 5% of the distance between Earth and the Sun. Such closeness has consequences that are both fascinating and brutal. One of the most striking features of Proxima b is its likely tidal locking. This means that one hemisphere of the planet permanently faces the star, drenched in unending daylight, while the opposite side remains in eternal night. Imagine a world where one side is bathed in perpetual light, irradiated by the star's energy, while the other lies in frozen darkness, a place where temperatures plunge far below any extremes on Earth. These conditions create a planetary dichotomy unlike anything we experience in our solar system. The day side would be blistered by constant radiation, potentially turning it into a barren desert, while the night side could be a frozen wasteland, devoid of any warmth or life as we know it. Yet amid this seemingly inhospitable reality, JWST has provided hints that not all hope is lost. Between the searing day and the frozen night lies a thin band known as the Terminator Zone, a twilight region where sunlight and darkness blend together. This narrow belt may hold the planet's most promising conditions. Temperatures in this area could be mild enough to allow liquid water to persist, creating potential oases of habitability. Water, the fundamental ingredient for life as we understand it, could exist here, shielded from the extremes of the surrounding hemispheres. Could life, if it exists, cling to this delicate edge of survival? Could microbial organisms, or even more complex forms, find refuge where the light is gentle and the temperature tolerable? The challenges, however, are not limited to extreme temperature contrasts. Proxima Centauri itself is a highly unstable star. Red dwarfs are notorious for their violent flares and magnetic storms, releasing bursts of radiation that would be catastrophic for any nearby planet. JWST observations indicate that Proxima Centauri's activity is even more intense than previously believed. Powerful stellar flares, capable of stripping atmospheres from planets, may strike Proxima b with alarming frequency. Without a protective atmosphere or magnetic field, the planet's surface could be exposed to high-energy radiation, from ultraviolet to X-rays, creating an environment that is lethal for most known forms of life. Yet there may still be ways for life to survive. Some scientists suggest that Proxima b could retain a thin, tenuous atmosphere, composed primarily of heavier gases such as nitrogen or carbon dioxide. Such an atmosphere might provide partial shielding from the star's radiation, reducing the destructive effects of flares. Additionally, interactions between the star's magnetic field and the planet's interior could allow Proxima b to generate its own protective magnetic field, much like Earth's magnetosphere protects us from solar winds. But even with such defenses, life would have to withstand extremes far beyond anything experienced on our home planet. The possibilities for life on Proxima b may extend beneath its surface. Subsurface oceans, warmed by internal heat or tidal forces due to its tight orbit, could provide a hidden refuge for life, protected from the star's relentless radiation. These subterranean environments could resemble the icy moons of our solar system, like Europa or Enceladus, where liquid water persists below a frozen crust. If such oceans exist, they would become prime targets in the search for extraterrestrial life, offering conditions that are both stable and potentially habitable. The potential life on Proxima b, if it exists, would likely be unlike anything on Earth. Extremophiles on our planet thrive in environments once thought uninhabitable, boiling hydrothermal vents, acidic lakes, and frozen deserts. If life has adapted to survive on Proxima b, it may have developed entirely alien mechanisms to cope with intense radiation, extreme temperature differences, and constant tidal locking. Life there could be resilient in ways we cannot yet imagine, thriving not in spite of the planet's hostility, but because of it. The implications of Proxima b extend far beyond biology. Its study forces us to confront our own assumptions about habitability, about what life requires, and about the fragility of our own planet. Earth, with its delicate balance of ecosystems, may not be unique. By studying worlds like Proxima b, we gain insight into the resilience of life and the conditions necessary for survival. We may also learn valuable lessons about safeguarding our own fragile environment, understanding that planetary destruction or survival can offer warnings for humanity's future. Humanity's interest in the system is already translating into action. The Breakthrough Starshot initiative aims to send swarms of ultra-small, laser-powered spacecraft toward the Alpha Centauri system, including Proxima Centauri. Traveling at speeds up to 20% of the speed of light, these nanoprobes could reach our stellar neighbor in just over 2 decades. The implications are staggering. For the first time, humanity could send objects beyond our solar system, observing another planetary system up close. Such a mission would allow us to explore Proxima b in unprecedented detail, potentially discovering signs of life or verifying its habitability. But even before we reach it, the question arises: should humanity attempt deliberate communication? Could Proxima Centauri already be sending signals of its own? What if the mysterious emissions from the system are not merely background noise? Could intelligent life be attempting to reach out to us? These questions challenge not only our scientific understanding but our philosophical and ethical perspectives. Are we ready to make contact with life beyond Earth? Or are we approaching a frontier that is best observed, rather than provoked? As JWST continues to probe this distant world, one truth becomes undeniable: Proxima b is far more than a scientific curiosity. It is a window into the extremes of planetary existence, a laboratory for understanding the resilience of life, and a reminder of the delicate balance that sustains our own world. The planet forces us to question the very definitions of habitability, survival, and life itself. Whether Proxima b is a refuge, a barren wasteland, or something in between, its study is bound to transform how humanity perceives the universe. In the end, Proxima b may hold answers to questions far larger than itself. Can life endure the most extreme and hostile conditions imaginable? Could life exist beyond the boundaries we once thought unbreachable? And what might that teach us about our place in the cosmos? As our journey into the unknown continues, one thing is certain: humanity's exploration of Proxima b is not just about finding another planet. It is about understanding life itself, in all its possible forms, and discovering what it truly means to survive in the vast, uncharted darkness of the universe. This is Discovery at 2.0, taking you to the edge of knowledge, revealing the mysteries of distant worlds, and exploring the questions that define our existence.